Hello, everybody. It's a pleasure to be here again in another webinar for Poultry School. Today we have the honor to have Mariel Neves Tavares. She right now is a technical and sales manager for Latin America for the company Yes. Mariel has a veterinarian degree from Brazil, a lot of MBA, business management, master's degree in animal science. And today, Mariel is going to speak to us about the basic tools for better immunology in poultry production. Hello, Mariel, how are you?
Hi, good afternoon, good evening for whom is evening
Oh,
at this moment.
oh, okay,
It's a
so
pleasure to be with you.
before to start, so for the audience, we're going to have time for questions at the end of Mariel presentation. That's the main meaning of having a live webinar. And our vision in Poultry School is having a virtual library of topics and education for all poultry markets. So after this webinar, maybe in the next 2 weeks, we're gonna be uploading this video in our platforms, in our YouTube and webpage, and then you will have free access for this seminar. So Mariel, the time is yours, and thank you for your time and for your for your information. Thank you, Mary. Go ahead.
Thank you everyone for the assistance. Thank you, Rodolfo and Poultry School for the invitation. It's an honor for me to be here, and I hope I can attend the expectation of everybody here. Today we're gonna talk about basic tools for better immunology in poultry production. All this information is obtained about in my personal experience. All the content I will be presenting here, the companies I worked for or that I am working nowadays is not responsible for the contents. Besides, some information is part of these companies' information. So if you have some question in the end, we can ask me online, or if you want, you can send me email by this email, Mariel.Tavares, yes.end.br. The agenda of these topics, we are going to talk about health problems in field. These health problems could be combated against with immune response, and then we can, as veterinarian, as agronomists, zootechnicists, as technical in field, working in broilers, we can use tools to improve this immune response. So this is the 3 topics we're going to talk about in next minutes. About health problems in field, we can see sometimes in some places in the world, situations like that, some buildings with high mortalities, and when we see day by day the increasing of the mortality already until 90%, 80%, and you can have many problems with the carcass of the animals. We can have many economic losses, so it's not desirable, this kind of situation. Other kind of problems, very common, very prevalent around the world, is the salmonellas. Salmonella is the food safety problem, and normally controlled by countries that buy final products from other countries by exportation. Brazil is a country that exports a lot, and we can have any positivity with salmonella in our products. So that's why it's very important to control this illness. And in field, we can see this animal prostrated, diarrhea, and we can see also necrosis in the extremities of the animals. Other signs we can find as salmonella diagnostics is some findings in organs that can give us the answer that is salmonella, and also the labs diagnostics. All these 2 examples I brought here, and also other illness we can find in field are generated by the pressure the infection pressure we can find in field, the stressful periods as transitions when we are transferring animals from a breeder to a production, a poultry, a broiler from the hatchery to the farm, from the farm to the slaughterhouse, or all of these moments are stressed moments for the animals. Also, we have environmental stress. We have stress generated by the transition in feeds from the initial to the growth and to the final diets. So all these moments could be delicate moments to the animal, that the immune system reduce your capacity of response, and also we have a very high infection pressure. So what I can see there in field, increase in feed conversion ratio, high cost medication, decrease in body weight, all these zootechnical parameters can lead us to the conclusion that we have immune challenge, especially when we have all this kind of problems. We are obligated to use antibiotics. And when we use antibiotics, we are inserted in a context as One Health, that is our response as veterinarian to reduce this use of antibiotics. So the most important when we see or when we don't see this kind of situation is to prevent the situation. To prevent the situation, what I consider is the most important tool is to have better immune response. And how does immune response works? I think, and to make it simple, we can make a comparison between a war and the immune system. We have soldiers in a battle during a war, and we have tools, we have equipments, we have arms, we have many tools that the two groups can use to win the war. Who is gonna win the war? The one who has more soldier or more technology to fight against the other one, the other group. So this is our immune system, the animal immune system. We have to work in external environment, reducing the infection pressure. How? Working on biosecurity, working on disinfection, working on density. Sometimes it's not possible to work on density. So we can use the other tools, external tools, to reduce the number of pathogens in the environment. And we for sure have a physiological capacity to in the animals of eliminate the pathogens, is the immune system. And especially when we have some gaps, this immune system is not good, is not working as we desire for this kind of challenge. When we talk about broilers, we have the first 7 days with a little protection obtained about passive immunity when we have the maternal antibodies received by the eggs. And then the next 40 days are a gap where the animal is developing their gut, developing their active immunity, they acquired by the animal. And then just until the 21st day on the flock, the animal will be prepared to fight against these pathogens. So what we have is to help the animals to improve this capacity of immune response, especially during this period. So that's why we can have some vaccination in the hatchery, and we can use some tools also in diet to supplement these animals during this phase of breed. The first response, immune response, are in the gut. Exactly in the gut, there is the system, there are digestive system that is developing in first days of breeding. So 70% of the immune cells that can make phagocytosis for the pathogens that the animal have contact are produced by the gut-associated lymphocyte tissue, the Gall cells. So we have to take care of these cells to have better immune response. It's the first step. When we talk about immunity, we have the first line of defense that are the epithelial barriers. The epithelial barriers are exactly the cells who's gonna absorb the nutrients. In between these cells, we have the tight junctions, the Claudin proteins. These proteins has to be integrated to have a mechanic barrier against the pathogens. As a second line of defense, in the intestine and in lamina propria, inside this barrier here inside, we can have the phagocytic cells that are the dendrites, the dendritic cells, the macrophages, the neutrophils, and natural killer, complement system, and immunomediators that can help the animal to eliminate the pathogens. This system works in the first minutes when the animal have the contact with the pathogens, hours or minutes. But when we would like to improve this capacity of immunity, we have to work on adaptive immunity. It's the third line of defense. When we're going to work in humoral-mediated and cellular-mediated, improving the capacity of B lymphocytes and T lymphocytes to produce more in macrophagic cells or to produce more antibody cells, antibody response. This is the way the organism works. We're going to show you a video explain how does this mechanism I mentioned previously works, trying to bring you some image.
Scattered along the intestinal mucosa are dome-like structures called Peyer's patches. These are enriched in lymphoid tissue, making them key sites for coordinating immune responses to pathogens whilst promoting tolerance to harmless microbes and food. The villi contain a network of blood vessels to transport nutrients from food to the rest of the body. Lymphatics from both the Peyer's patches and villi drain into the mesenteric lymph node. Within the villi is a network of loose connective tissue called the lamina propria, and at the base of the villi are the crypts, which host stem cells that replenish the epithelium. Finally, the epithelium, together with its thick overlying mucus, forms an important barrier against microbial invasion. Embedded within the matrix of the Peyer's patch is a mix of immune cells including T and B lymphocytes, macrophages, and dendritic cells. A key function of the Peyer's patch is the sampling of antigens, in this case mostly bacteria and bits of food. To facilitate this, the Peyer's patch has a much thinner mucus layer as well as specialized phagocytic cells called M cells, which can transport material across the epithelial barrier via a process called transcytosis. Finally, dendritic cells are able to extend dendrites between epithelial cells to sample antigens that are then broken down and used for presenting to lymphocytes. Sampling antigens in this way typically results in so-called tolerogenic activation, where the immune system initiates an anti-inflammatory response.
So as you could see here in this video, the main tools we have naturally in the animal metabolism are the protective cells in the immune system that are produced in lamina propria and can go between the tight junctions to help the animal to not allow the infection of these pathogens, agglutinating these organisms. So when we have more soldiers in our immune system, in the animal immune system, then the pathogens present in this environment, there is the gut environment, probably we will have a victory in this battle. So first step, is to work on tight junctions, is to protect and to make the integrity of these tight junctions. And second step is going to be working in animal adaptive immune system. What is the tools we have to do it? We have the most common tools, as we already know, the vaccines that we can use in the hatchery or in the breeders use since the first weeks of life to protect this animal to all life, and also to have the capacity to transpass this immunity to their descendants, to the broilers. And also, nowadays, we're talking about some tools that we can use, can apply on diet supplementation. For example, beta-glucans. Beta-glucans are one of the tools that are most studied in last 20 years, that can be provided by bacterial, by fungal, by yeast, by cereal, and also by algae. Today, we're going to talk about the yeast, the beta-glucans provided by yeast, because they are the long and branched chain of beta-glucans, and then they can have better results as immunomodulators, according to the trials we have studied. And also, finally, we're going to present other molecules. There is MSP. There is not a beta-glucan, but it's a polysaccharide obtained by seaweeds. So first, talking about beta-glucans. Beta-glucans are presented in each or any yeast we can find as Saccharomyces cerevisiae. They are part, the internal part of the yeast wall. So if you use dry yeast or hydrolyzed yeast or yeast wall, you can find beta-glucans. But these beta-glucans are linked to all the structure of the yeast wall, including the monoligosaccharides, including the other glucans, and it's not available to be agglutinated. And when we work in hydrolyzed process with specific enzymes, we can purify these beta-glucans, as you can see in this image. The beta-glucan is the white part, and the black part is the yeast cell wall. Here you can see the unicellular unit of the yeast just right. Then the first process in hydrolyzation, we can obtain the yeast cell wall. And when we have more and more hydrolyzed, enzymatic hydrolyzed process, we can obtain these micronized structures of the beta-glucan that can be absorbed by the phagocytic cells. And what is the result we can find? When we induced some rats with salmonella, these rats have a high mortality and a high feed conversion ratio. But when we use a structure of yeast that contains monoligosaccharides that has the capacity to agglutinate salmonella, specific salmonella and E. coli, and we have internally the portion of beta-glucan that can stimulate a little pro-inflammatory response in these animals, we have a kind of decrease of this mortality. But when we use a purified beta-glucan as prevention, these animals have the capacity to eliminate the salmonella by their cells. And this reduces also the feed conversion ratio. So what do we want when I have an infection pressure? Reduce mortality, reduce feed conversion ratio, and have more money. So this is what we can have when we have health challenge in the animals to reduce mortality and use of antibiotics. The monoligosaccharides that is outside of in the external part of yeast wall have the capacity of agglutinate salmonellas and E. coli. And the beta-glucans have the capacity to activate the toll-like receptors 2 and 6. And this capacity can induce the animals to produce signals to recruit more cells to make more phagocytosis. And that's what we want when we have a pressure infection, a higher pressure infection in the animals, to minimize the effects of these pathogens, to reduce the capacity of the animal to being illness, to have the necessity of using antibiotics, and also to have mortality in our flocks. So when we make an evaluation of induced LPS, lipopolysaccharide, in macrophages, in low infection, we don't have too much difference between this group that is the beta-glucan purified and a beta-glucan not purified. But both has better response than when we don't use any tool to increase the immune response. The animal has the natural capacity of induce a response and promote recruitment of new cells. But when you use tools to improve this, you boost this capacity. You improve the capacity of produce more interleukin-6 that is pro-inflammatory. But some minutes after, it's important to induce also the interleukin-10 that is an anti-inflammatory interleukin. And then here we can find difference between the beta-glucan purified in this group and beta-glucan not purified. When we increase the induction of LPS, simulating a median challenge in field, we have an increase in this between this difference. With the control group that has no tool to improve immune system, the beta-glucan purified and the beta-glucan not purified, even to pro-inflammatory marks and to anti-inflammatory marks. When you put some 10 times more challenge, LPS challenge, simulating a high pressure, a high infection pressure in field, we have different numbers here in production, interleukin-6 and interleukin-10, also for pro and anti-inflammatory. This is the mode of action that can prove us that these two are immunomodulating, not are immunostimulating. Because when we just stimulate an inflammatory response, we are using metabolic energy. And when you use metabolic energy, we are tipping this energy from the other parts, the production we have to do in case of broilers to gain weight. So to make the animal grow and to gain weight. The other proof that this situation, this tool we work with, the beta-glucans, has a good response as modulating, is a flow cytometry methodology that can measure the activity, the phagocytosis activities for each number of cells. So we use a control group with no tools, and then another group with beta-glucans purified for 12 days. In 12th day, we collected samples of serum in the blood, and we could find less quantity of monocytes as phagocytic response, but these less monocytes could produce almost the same and a little more activity as phagocytic activity than the group control. And also the same tendency was observed with heterophilous cells. The number of cells was a little less and the activity in phagocytic action was increased. Some publications we could find in 2015 with rats, they induced a challenge with avian influenza and fed the animals with beta-glucan purified for 14 days. And they have 6% higher the survival. So 6% or more of the flocks compared induced with influenza virus was survival compared to the group that didn't use any to improve the immune response. The same trial has proved the presence of the virus in lung, and the white bars can demonstrate that the number of virus, the titer of virus in blood, is less than the group that didn't use any tools. So it has effectiveness, capacity to reduce the presence of the virus in lung. Also, they could measure the activities of phagocytosis for neutrophils and natural killer cells. And that's why they probably reduce the presence of the virus in lung, because in the bare white we can find a better response in phagocytosis for neutrophils and also for natural killer cells. And how they made it? They constructed a better number of antibodies against avian influenza. Regarding this flocks were challenged in the first days and had to be fed 14 days with the beta-glucans diet. This same trial demonstrated the presence of interleukin-1 beta and interferon-1 gamma in lung, and both could present an increase of these signals to recruit more cells in the group that has the tool to improve immune system. So they have the capacity to improve the recruitment of new phagocytic cells and eliminate more the number of pathogens. And in this case, who wins the war? The group that use beta-glucan purified. In other trial in 2019, broilers were observed for 42 days, and they were vaccinated day 7 against influenza, avian influenza. What they measured mainly as benefits was 13% more of a phagocytosis activity in mononuclear cells with the beta-glucan group, beta-glucan purified group. And they evaluated on day 1, 2 weeks after vaccination, and 3 weeks after vaccination, 37% more antibody titers in this group at 30 week after use of a vaccination. So these tools can help the animals to increase antibodies, so their immune response are better, also an innate or inadaptive response. That is the results I can share with you for beta-glucans too. But also I'd like to bring you a new biotechnology that is named MSP. That means marine sulfated polysaccharide. Marine sulfated polysaccharide is obtained by algae, by seaweeds, macroalgae. It's identified chains that has specific characteristics, and one of them is to protect exactly the tight junction barrier, and the other one is to stimulate the immune response as comparative we're mating with beta-glucans and monoligosaccharides obtained from ECO. So the first one is gonna reinforce the tight junctions, making better the quality of the cloudings here, and in making this barrier, the mechanic barrier, to not allow the pathogens to enter the organism. We can find in vitro results of maintenance of this barrier function. Looking the blue bars represented the MSP results for the expression of proteins that represent the tight junctions structure. And then the increase of mucin 2 and mucin 4 that represents the quantity of mucin produced by caliciform cells. So this MSP has the capacity to maintain the integrity and the functionality of the cells in gut, protecting as a mechanism, as mechanic, as chemical, the intestine, the gut, and then making a better response and preparing this intestine to receive the MSP immune. The MSP immune has the same characteristics of beta-glucans acting in toll-like receptors 2 and toll-like receptor 4 that could be proved also in vitro trials, where we have a negative control and a positive control with 1 kilograms per ton of this MSP immune, where you could measure interleukin 8 that it was gonna be recruit neutrophils, interleukin 1 alpha that's going to recruit and make the differentiation of B and T lymphocytes, the CCL20 for B and T lymphocytes and also to dendritic cells, and the TNF-alpha to macrophage stimulation. And the most important was the parameter to measure the anti-inflammatory activity. The anti-inflammatory activity measured by EL10 is better than when we have a negative control. This is interesting because we have to have this modulation to guarantee the animal is not consume their weight gain and their feed conversion ratio. This is the mode of action. So it's to protect the gut, the barriers, maintaining the integrity, to not allow the pathogens to enter in the intestine, and then make better the capacity the animals of producing more phagocytic cells. All these one are phagocytic cells, and I am improving with these tools the capacity of the animals to produce more of these cells to make more phagocytosis and eliminate the pathogens. When I put this in a trial in vivo with animals vaccinated against Newcastle on the day 1 and the day 40, evaluated until 35 days, these animals could be presented immunoglobulin A 44% more increased than the control group, and this makes have some consequence, because when we have less diarrhea, when we have animals feeling better, eating better, gain more weight, these animals probably will have less pododermatitis in the day 35. That is a final product that in many countries is very important. And also we have all the so technical parameters better. So we have a final weight gain increased for the MSP group. The feed conversion ratio also better because they reduced the mortality and they reduced a lot the score of pododermatitis. And this represents, when we compare in euros, 6 cents of euros per chicken in return of investments with this kind of tool. So my main message for you is when we use correctly the supplementation of poultry diet, we can improve the immune system, decreasing illness occurrence, mortality, and antibiotic uses. So the importance of us as veterinarian in One Health programs as food safety, and also to have money to the producers is these 3 main points. This promote better economic results. So making everything simple, we have to win the battles in the world. We have to improve, we have to to recruit more soldiers than the pathogens. And we have to be more effectiveness than the pathogens to win this war. And this is going to return us as economic benefits. So this is the message I have for you. Thank you for watching, and I will be here for any doubt we have.
Fantastic, Mario. I think that was a very nice presentation and very clear. Again, as I say when we start this webinar today, is I think that putting in the hands of the industry this information and trying to collaborate in a common way to improve the way that we produce animal protein is a key element for the industry. And mainly when we have all these challenges right now, mostly globally, avian influenza, for example, but there is another threats in the health industry, and maybe the people that we are inside the industry, we know better and we know certain things that maybe the people that are not related to the industry, they are very scared. They have a lot of questions. They don't know the answer. So I think it's a lot to do in the industry, and we appreciate your time. I don't know if there is any questions from the audience. If not, this video is gonna be open maybe in the next week. We have Mr. Sanam raising the hand. Can you put the questions in the question and answer box? You have a question and answer box. Let's see. Or maybe, let's see. Let me see where I have this. If there is a question. Okay. Aaron Londi, you can speak if you have a question. You have your mic on mute. You raise the hand. Aaron Londi. Okay, here is a question. Mr. Sanami is typing something. Okay. So, but that's what I think, Mariel. Many people that we are in the industry, we know a lot of things. We know how we produce the meat and eggs, but so many people are outside our industry, our family, our friends. They don't know really what they're doing, and sometimes the news are not the better, the media. Okay. So there is a question. Can you see it, Mariel? How can
Yeah.
minimize the use of antibiotics? Because in Pakistan, antibiotic uses may use it with heavy dose.
Yeah. Thank you for your question. Here, I presented some tools that we can apply by diet to reduce antibiotic use. But the most important, when we think in antibiotic use, we are thinking in growth promoters and in antibiotic as therapeutic uses. Both uses are reducing around the world nowadays because we have another kind of tools. We have natural tools that can not generate resistance in the bacteria, and we can use it as programs, as antibiotic-free programs. Is for sure not recommended to replace totally the use of growth promotes by other tools. Then from one day to another one, we have to do the programs day by day, looking and following the results, following the challenge, the health challenge, and the antibiotics uses. What the most value tool I really know around the world nowadays is the immunomodulators. Is also for us when we were in pandemic situation, all people were looking for immunomodulation, immunomodulators tools to protect themselves against COVID virus. So the concept is the same we had at the moment for human population to our animal and broiler population. We have the opportunity to give these animals the better capacity to respond by themselves against the pathogens and reduce the use of this kind of tools, the traditional tools as antibiotics. Was the influenza a field strain or vaccine strain? In these trials was one trial is field and not field because it was induced in the trial in the animals, and the second one was a vaccine challenge. The first trial I demonstrated was from field, and the other one was from vaccine, was animals, vaccinated animals.
Okay,
So,
perfect.
just to have an end about the antibiotics usage and the external actions we made as biosecurity, densities, and disinfections, as I mentioned previously, is also important to make this reduction in antibiotic uses. Thank you for your questions.
Okay, perfect. Thank you, Mariel. I don't think that we have another question right now from the live audience. Like I say, this video will be posted soon in the next couple weeks, and then we will share your contact. If anyone that is hearing right now, or to all the people that was registered, they can access you and have more information or more insights. So, Mariel, I really appreciate your time. I really thank your willingness to provide value to the industry in this platform. Like I say, one of our main visions, again, is to provide a virtual library of information that everybody anywhere in the world can access and have information from the experts. Okay, I think we have one last questions.
Yeah.
And will be the last one, somebody anonymous. You can read it.
Yeah, I read it. Increase biosecurity. Biosecurity is education. Biosecurity is where we walk, where we live, where and with whom we live. Is very difficult to make all implementations in biosecurity, but I've been working for grandmother's farm. We made 100 of actions to improve more biosecurity in farms. I can share some documents, but I think it's the good agricultural practice applied to the farm is the way we have to educate people who is working on farm. And for sure, we have some investments in the structure, in the buildings, taking care of where these buildings are built. If it's close to roads, the way the trucks enter the farm, if it's enter or not, if it's possible to not enter better, if you wash the trucks who is going to leave food for the animals. So all this process is very important to be very restricted, and all this be much controlled to improve this biosecurity. And I think it's another question. What's the
Yeah,
role
have
of
a more couple minutes. Yeah, go ahead.
The probiotics is also good to improve the immunity because of the reason we mentioned in some of the slides. that 70% of immune cells are produced in gut. When we have a good health in gut, we have integrity, we have all the mechanisms working well. So when we put probiotics, we have better quality of these cells, better integrity. That is the same action we have with monooligosaccharides, we have with acids, organic acids, or we have, it's not the same mode of action, but the main target is to have a better gut health. And with better gut health, everything's gonna be working well, gonna be work better, and the cells will be more integrated, and we can produce more immune cells, and these immune cells can have a better work in gut, in lamina propria. That's why it's a tool that able the animal to have a better immunity. It's not the same concept we are talking about here, that was immunomodulation, because we have a direct action in immune system. It's an indirect consequence we have when we use a probiotic in the intestine.
Perfect. Again, Mariel, thank you very much for your time and your value sharing with our audience. And we're going to be closing this live webinar. And again, we're going to be sharing this. Let's see. For giving accurate. Okay, so there is just appreciation from Dr. Aaron, and saying thanks for your value sharing and for these answers. Okay, and that's really important for us also, receiving feedback from our audience, and we're very excited. In my particular case, adding value and being connected with people in Pakistan in something very nice, Mari, and I think that also for you.
Thank you, everybody, for the assistance. I will be able to answer your questions by email if you want, and if you have some questions more. Thank you, Rodolfo, for the invitation again. Thank you for your time, everybody.
Thank you. Bye-bye, guys. See you.